The next video in our series on triangles, our third video now, is going to be on two different types of triangles. So the first one we're going to talk about is isosceles triangles. And I have a friend here with me, this little angry bird that's going to help me describe the parts of an isosceles triangle, just to review. So if you think about this angry bird, if you look at his eyelashes right here, or his eyebrows, these guys represent the congruent parts or the congruent legs. So remember that the two legs of an isosceles triangle are congruent. Now what I want you to remember is that anytime on a picture, if you see the congruent legs marked, you can automatically mark the two angles. So you can think of those as kind of his eyes down here, or his cheeks. So these are the base angles. So anytime that you have your legs marked as congruent, you can also go ahead and mark the base angles as congruent. So for example, let's say that you had something, like this, just an example, and they gave you this picture and you knew that. You can go automatically and just mark that these sides are going to be equal. So you can see those are his angry eyebrows and here are his eyes or his cheeks. Okay, don't get disturbed if you see something flipped around. So let's say that you saw something on its side and this time they had these two marked. Well, think about it flipped. Okay, this is the base down here, so that means this must be the vertex. So then these two are automatically equal. So see, his hair is up there as the vertex. So just remember that. In the examples we're about to do, remember, these legs are congruent and so are the base angles. Even if they don't have it marked, go ahead and mark it. Alright, so let's take a look at some examples of what you might see. So the first example, let's say that we have a triangle that looks like this, and they have these angles marked, but we have a 20 on the outside and a 3x minus 7 on this side. Now according to our rules, that these out here are sides. The 20 and the 3x minus 7 are sides. So you can't equal them to 180. But remember the rules of your isosceles triangles. If these two are marked, automatically go ahead and mark those sides. It's automatic. Then, since we know that these sides must be equal, we can go ahead and set these equal and solve for x. Then we'd add 7. So 3x equals 27, and then x would be 9. So one way we can solve for x with the sides is just to go ahead and set them equal. Alright, another example you may have, let's say they give you something like this. Okay, this time they give you the sides marked, and you have a 50 down here in the corner, and you have an x up at the top. So we need to figure out how much this is. So let's fill in the picture. So again, we know that these are the eyebrows. So these down here must be the cheeks or the eyes, and this is the hair up at the top, or the vertex. So if this is 50 according to the base angle, this other side over here has also got to be 50 because the base angles are going to be equal to each other. So you can go ahead and fill that in as 50. So if you know these two are 50, how much is the inside of a triangle? Okay, if you remember from last lesson that it's 180. So if that's 180, I'm going to subtract from 100 and I'm going to get 80. So my top angle or my vertex that I was looking for is 80. So these are just a couple of key points or things that you can use if you see pictures of isosceles triangles. Okay, let's take a look at two more that are a little more complicated. Alright, example number 3. So let's say that we have a tall guy here. Okay, and we have these marked. We got an x down here, and we have a 40 up here. So let's go ahead and again mark in the spots. So if these are his eyebrows, these can be marked automatically, and up here is going to be your vertex. So 40 is your vertex, and you got an x down here. So if this is an x on this side, what is this side over here going to be with the question mark? Well, if this is x and they're equal, then this also, you can fill this in as the letter x. So even though you didn't start with it, you still know they're equal, so that means that they're both going to be an x. So now we're going to have to set up a formula to solve for x. So again, you know that the inside equals 180. So we're going to go part plus part plus part, or x plus 40 equals 180. Then we can add them together. 2x plus 40 is 180. Subtract 40 on both sides. So I'll get 2x equals 140, and then divide by 2, which is 70. So each of these base angles down here have to be 70 in order for it to add up to be 180. Alright, one more example is something like this. So I'm going to flip it on you here, upside down. I'm going to mark those, and I'm going to throw in this as a 2x and this as a 6x. So again, just to get used to it, because I think if you keep marking these, it'll start making sense and you know what's equal. So this is a flipped upside down little birdie. We got his eyebrows here, so that means that his eyes are down at the bottom, or the base, because this is your base, and your vertex is right here. So, we have no degrees. We know that this top angle is 6x. We got 2x in the corner. What's over here in this side? Well, you bet you're thinking it. If this side is 2x, this side also must be a 2x, because the isosceles triangle rules state that the base angles have the same measurement. So you can go ahead and fill that in as a 2x, because this side was 2x and they're marked equal. So now we can set up a formula, because again the inside is equal to 180. So 2x plus 2x plus 6x equals 180. Combine your like terms. 10x equals 180 and x equals 18. Voila! Alright, I'm going to give you a little halftime entertainment while we move on to the next one. We're going to just do 1 minute on the equilateral triangles or equal angular triangles, because that can also help you solve some of the next steps that we may have in a triangle. Alright, so the last one, just to give you a couple tips. Again, all of these are tips or examples to help you when you're trying to do some of your work in class on different pictures. So just think about what are the rules of isosceles, what are the rules now of equilateral. Remember, equilateral and equal angular are basically the same thing. The only difference is equal angular means equal angles and equilateral means equal sides. So if, let's say, you look at a picture and you see that all of the sides are marked with the slashes. If all of the sides are marked with the slashes, you can automatically assume, you can automatically go ahead and mark all the angles are congruent. Because if these are all, then these all have to be equal. So they all get marked with one swoop, meaning that they're all the same. Now we also learned, and I kind of said this before, that if the whole inside of this triangle is 180, and they all have to be the same, there's only one possible way that can happen. So if I divide 180 by 3, I'm going to get 60. So all of these angles are automatically 60 every time. There's no other way that it could happen. If you went 50, 50, 50, you get 150. Wouldn't happen. 40, 40, 40, 120. Not going to work. So 60, 60, 60 is the set number for equilateral, equal angular every time. So the same thing goes if you're looking and you have a picture that's marked with all swoops. If you see that, just go ahead and automatically start marking the sides. So you have that, hey, this is automatically going to be marked with all the sides, and I automatically know that these have got to be 60, 60, 60. Now the reason that I show you this is you might see some examples coming up where you have a picture like this and they may just throw some numbers like 40 and 2y. Okay, it's the same idea. If it's equilateral, they got to be the same. Go ahead and set them equal to each other. Divide by 2, and you get y is 20. Alright, one more example, just a little more difficult one. You might have something like this where they're going to connect isosceles, equilateral triangle was something else. Let me see if I can draw this right. It's not very easy to draw. So let's say that you have something like this, right? And they mark these right here. And then the only other thing they give you is a 30 up in this corner. Now, because you see that this is equilateral, what did I just tell you that you can assume? You can go ahead and assume that these have got to be 60. So you can go ahead and write 60 in every corner right here. So if that's 60, hopefully a bell is ringing, ding, 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 ding. I have vertical angles right here, wham, bam. So if this is 60, you can go ahead and write 60 up here as the vertical. Now, if they give you 30, you can easily figure out, the triangle is 180, so 30 plus 60 gives me 90. Subtract from 180, and bam, we got a right angle right there. Okay, so just something for you to think about in the upcoming lesson.